The purpose of this particular talk is essentially to describe some of the research we've been doing for a number of years around a variety of programming languages, Java among them. Can I get a show of hands? Who in this room knows what an industry analyst is and what we do? All right, that's pretty typical. So that's about 3 hands, maybe 4. So basically what we do is we research software, we research trends, we research programming languages. We gather as much data as we can, and we try to figure out, based on where things have been, where things are now, and most importantly from our perspective at RedMonk, what all of you think of technologies, what you're using, why you're using it, what works, what doesn't. And we attempt to extract from that ideas as far as where things are headed. So what I wanted to do today was 2 things. So first of all, trace, as the title describes, essentially the rise and fall and subsequent rise of Java. And when I say Java, I'm primarily talking about, well, for the most part during this presentation, I'll be talking about the language, but I'll be referring to the platform as well. But just as importantly, to try to extract from that a couple of lessons as far as things that the wider Java community, of which you guys in the room are certainly representative, an idea of how you might improve things, how you might continue to grow, how you might push towards greater ubiquity and growth over time. So, the rise I probably don't need to describe to many of you because many of you have lived it. I'm sure some of you are familiar with the history. The project began as a stealth project at Sun Microsystems in 1990. It was certainly not conceived to do all of the things it does today, like so many pieces of technology. And in fact, its first actual project was as a cable box operating system. This was, it was sort of pitched for this. I think it was Time Warner, and it failed. It did not get that contract. This was, I think, in '92. '94, however, the web blows up. A whole bunch of things happen all at once. 1994 and 1995 were very big years in the technology industry, which see the introduction of pieces, Netscape Navigator in 1994, MySQL, Apache, and a whole range of other subjects in 1995. And really the history from a Java perspective reflects that. So for a long time, TOB was, I'm assuming some of you in the room have looked at the TOB rankings. Anybody? Okay, we got a couple hands. So for many years, TOB was the only sort of, the only outfit that was tracking programming language popularity, programming language interest, and so on. So I don't know if you can make out the chart here. It's pretty small, but the basic idea is that in 1996, Java was, by their sort of rankings and by their metrics, the 6th most popular language in existence. And 10 years later, it was #1. And sort of beyond that, I mean, yes, it's #1. Yes, it sort of performs well on this particular metric. But the really important thing, for the industry as a whole, is that Java spanned this tremendously large ecosystem. And again, I'm not going to dwell on this. Many of you have benefited from this. Many of you, in fact, were a part of it. But we're talking hundreds, thousands of applications. We're talking hundreds of businesses, some of which were very small, some of which were very large. And this was the ecosystem that was spawned by this project, the stealth project, as it was called sort of initially. And again, none of this was anticipated. It grew into this effectively de facto duopoly, right? So for many years, if you were building software to business, you sort of officially had 2 choices. You had the Microsoft ecosystem or you had the Java ecosystem. Now, many of you in the room probably know that that was never actually true. There were a whole bunch of other things that were going on under the covers that subsequently have been exposed. But for the most part, if you were building an application, it was going, most likely going to be part of one of those 2 ecosystems. So this was the rise. So from its inception in 1990, through the mid part of the last decade, Java was the biggest ecosystem on the planet. Simply because relative to Microsoft, it had many, many more commercial participants, who were able to actively build out that ecosystem and make it sort of the phenomenon that we all know today. The fall, came sort of gradually. The fall came gradually enough, in fact, that many of the people, even involved in the project, many of the people involved in the ecosystem probably didn't, feel it at the time. It was subtle enough and, essentially not obtrusive enough that it really took some people by surprise, in spite of the fact that the signs were there. So one of the arguments that you might have heard made, certainly in recent years, there are people who compare Java to COBOL. All right, so COBOL still exists. It was just actually ported to new versions of the mainframe, so it's going strong. It powers, critical applications all over the world. It is, all of that said, probably not the most dynamic and refreshing environment for people to program in. So that comparison is one that typically rankles Java people. But at least on the age front, there is some truth to it. All right. So there's a company called StatWing. They make essentially an online analysis tool. And what they did is that they ingested a data set, a survey of 10,000 developers that was done by the folks from Stack Overflow. How many of you in the room use Stack Overflow? Okay, that's most of you. So Stack Overflow, you have a general sense of that population. It's obviously, well, primarily, if not wholly developer-centric. And really what they found was that there is a statistically significant correlation between age and Java. Now, it's weak. You can't, what that means is that you can't look at this and say, okay, because somebody is X age, that means they use Java. But there is a statistically significant correlation, and that correlation says that the older you get, the more likely you are to use Java. So on the one hand, that's great. There's years and years of experience. That means you have a sort of deep talent pool to draw from. On the flip side, it's not as good because it means that sort of the young people coming into the industry are not as likely to be using the platform or the language. And one of the things that sort of people, when we've talked to businesses that are in the Java ecosystem, for a while, they'll sort of push back and say, well, look, our numbers are really good compared to things like C and C++. We look great. And in fact, that is true. So this is data from Olo. Olo, basically, for those of you who are unfamiliar with them, is run by the folks in Black Duck. Basically, they go out and index open source projects, really that are publicly exposed. So they don't have good visibility into the enterprise where Java is strong, but they do have a good sense for, in the sort of increasingly wide world of code that's available on the web, who's using what, and more specifically, within those trends, where are they headed? What are the trajectories? So what you can see here is if you go in and look at the commits, and this is over a multi-year period, for Java versus C and C++, Java actually performs reasonably well, right? I mean, it never matched the heights from a commit perspective that C and C++ saw, but at the same time, it has not experienced a dramatic drop-off in growth. Basically, what this says is that the Java ecosystem from a commit perspective has been strong for quite some time and remains so. So this is, again, it's a sort of very valid piece of pushback that we get from essentially people who want to defend the Java ecosystem. The difficulty is that if you compare it to some newer platforms, it doesn't sort of compare as well. Now, you have to take into account here that growth is a very relative thing. And the way that we explain this is that it's much easier to double my income if my income is $500 than it is if it's $5 billion. Right? So growth needs to be taken, not sort of as an end-all and be-all, but at the same time, what we're seeing from a variety of platforms, JavaScript probably the most notable lately, is dramatic growth in terms of the overall commit volume. So the sort of then static performance of Java commits over time is a little bit more troubling. You're not seeing some of the same growth that you're seeing from emerging platforms. And it's not just in terms of the total commits. These are the Olo numbers for monthly contributors. And the interesting thing is that one of the last times I talked about this subject in terms of tracing the arc of where Java has been and where it's going, was in 2010, and JavaScript hadn't passed it yet. So, you know, when we reran these numbers and looked at them, it's you know, sort of interesting and potentially troubling from a Java perspective to see that JavaScript, at least for a monthly of the monthly contributors that Olo has visibility into, is now a more popular platform than Java. And we see exactly the same data when we look at the monthly projects. You know, so the total volume of projects that Olo is tracking, again, you know, we see sort of decreased traction from the Java side and increased traction from platforms like JavaScript. Now, it's not just the data that has been telling us that, you know, there are some changes going on in the Java ecosystem. You know, that it's not just the sort of data making the case that Java is quote unquote in decline. Analysts have been making this case for a couple of years. Many of you may have seen these reports. This is from Forrester. This is a gentleman by the name of Mike Gualtieri wrote a piece, Java is a dead end for enterprise application development. This was in 2010. His colleague later followed up, John Reimer, followed up, I believe that was in, what, 2011. And basically, you know, what you're seeing then from application analysts is skepticism. Skepticism of the future of Java, skepticism of the future of the platform, skepticism of the future of the language. And they're looking at some of the same data sources that we are, but they're also, you know, involved in talking to businesses about their usage. So they're coming to conclusions that suggest, yes, you know, hey, the platform is in decline, which obviously has implications for everybody in the room. You know, other events, you know, certainly have not helped matters. Many of you probably remember, or actually still read about, you know, the ongoing appeals around the Oracle and Google litigation. This, you know, from our experience, as I'll show you in just a moment, had a chilling effect in terms of interest and participation in the Java platform for a couple of reasons. You know, first of all, it raised questions as far as, are my skills going to be transferable from, you know, the Java world over to this mobile world of Android? Or, you know, is Google going to be forced to completely redo that platform? It also raised questions about sort of the nature of Oracle and, you know, the nature of their stewardship. So what we began fielding from developers, you know, which are, it's the audience that we care about most, the audience that we believe is going to, in the majority, if not all cases, dictate the future of technology, was profound concern. You know, so we have a system called RedMonk Analytics. In part, what it does is that it looks at what developers query our content, right? So we make, you know, we produce research, we make that research available for free on the web, and then we watch what developers do with it. We watch the interest they have. You know, we watch their concerns, we watch their queries, some of which actually are quite amusing. But in this case, you know, really a couple of the top concerns, and this is for the entire calendar year 2010, centered around Oracle and Google. So the fact that this sort of occupied so much, you know, sort of attention, sucked up so much oxygen in terms of the conversation around Java and the conversation around the Java ecosystem is not a good thing. And likewise, you know, we saw, you know, a great number of issues, you know, associated with the sort of ongoing strife between Oracle and some of the open source communities, most notably Apache. So, you know, you combine all these things, and any one of them in and of itself isn't a big deal, but they become a bigger deal in the context of language fragmentation, right? So as we talk, this is, you know, sort of a concept that a lot of people kind of struggle with. But what we mean by this is actually pretty simple. You know, if, as sort of we talked about earlier, the de facto standard for most businesses for a very, very long time was that you were using probably one of two languages, probably something in Java, probably something in Microsoft, and, you know, some combination in many cases, you know, if not, you know, sort of strictly one or the other. That's no longer the case, and that hasn't been the case for a long time. You know, the fact is that if you go around to any enterprise now, they're likely to be using any one of a dozen languages. You know, they're using different languages because they're different tools to solve different problems. You know, some of these languages, you know, may in fact be based on the JVM. You know, I came in to the tail end of this last discussion, you know, talking about Scala and Ceylon and Groovy and things of that nature. But, you know, the fact is that many of them are using languages that have nothing to do with Java at all. right? You know, we're talking about things like Ruby, Python, Perl, JavaScript, PHP. The fact is that Java, the language, faces far more competition than it did a decade ago, because we no longer have that sort of artificial duopoly of you need to use this application or you need to use that application. Developers are now making choices for themselves because they can, and not surprisingly, when you have a group of individuals making individual choices, there are a lot more of them being made. So that's all sort of doom and gloom. That's all the decline. That's all the bad news. But what about the rise? You know, this is something that, you know, with all due respect to my sort of analyst colleagues, I think gets missed and I think gets lost because people focus on the wrong pieces. They don't look at the bigger picture. They don't look at sort of what's going on in the larger context. All right? Because from where we sit, when we talk to developers, there is still a tremendous amount of interest and a tremendous amount of vitality in the Java community, and that gets lost. And that doesn't necessarily translate. So as an example, this is an eye chart. You're not meant to read it. Has anybody seen these graphs before? Okay, we got a handful of hands. Basically what this is these are, we do language plots once a quarter. We haven't run the numbers for Q2 yet, so this is Q1. But basically this is based on research done by a couple data scientists, Drew Conway and John Miles White. And ultimately what it does is it compares two communities. All right, so on the one axis, you know, we have GitHub. On the other axis, we have Stack Overflow. Because what they decided was that they wanted different communities. They didn't want to, for example, just rely on GitHub's assessment of, hey, what languages are popular? Because in spite of GitHub's size, you need some checks and balances. You need some representation for different communities. And in spite of the fact that GitHub and Stack Overflow are, you know, have a huge amount of overlap in terms of users, and you know, are aimed at the same audience in terms of developers, you actually see a lot of individual differences between them. You know, there's actually quite stark differences between them. Excuse me, Ruby, for example, performs very well in GitHub. It tends to perform slightly less well on Stack Overflow. C#, on the other hand, possibly as an artifact of the fact that the founders of Stack Overflow were themselves out of the Microsoft development tradition, tends to have C# perform much more strongly. So what we see is two communities that are very, very developer focused, that attract an enormous amount of attention and time from developers, and yet exhibit some sort of slight differences. So what we sort of rely on them for is to be somewhat predictive. As I said before, we're believers that developers are defining sort of the next steps for technology. What all of you in the room use will have a stronger say in sort of the future of the Java language and the future of the Java platform than anything analysts like myself say. You know, we take our cues from you. We don't try to set those cues, because ultimately you guys are the ones who are empowered, you know, as far as setting the technical direction. So when we try to draw our conclusions from what you're using, we turn to behavior, we turn to usage. So in the case of GitHub, we're looking at effectively what code is being sort of maintained in public repositories and what languages is that written in. On the case of Stack Overflow, on the other hand, we're looking at commentary. We're looking at the volume of commentary around particular languages. We do that through tag volume. So what we end up with is a plot which basically just correlates the rankings in each of these two communities. And what Drew and John found is the same thing that we found, is that the correlation is exceptionally strong. So their correlation, I think, when they ran the first iteration of this plot was 0.78. If anything, it's gotten stronger over time. The last couple of editions, I think, have been 0.81, 0.82. And what that means is that, you know, almost 80% of the variation in sort of one side of this graph can be attributed to changes in the other side of the graph. It means that more often than not, they line up. But the bigger finding, you know, from our perspective was ultimately, and as I said, you can't see it here. If you Google RedMonk programming language rankings, you'll find these. Was that the languages ultimately separate themselves out into tiers. So, you know, at the upper right-hand corner of the graph, you have a small tier of sort of what we consider to be tier 1 languages. A little bit further down from that, you have a sort of larger grouping of what we consider to be tier 2 languages. There's roughly a sort of group of tier 3 and tier 4 languages. And the interesting thing from the perspective of all of you in the room is that Java has never not been included in that tier 1 of the first grouping of languages, but more importantly, it's never really been outside of the top couple. And again, in GitHub and Stack Overflow, I mean, these aren't exactly legacy properties, right? You know, these aren't exactly the kinds of properties that are, you know, sort of reflective of enterprise tendencies. You can't argue that GitHub or Stack Overflow are strictly representative of, you know, quote unquote enterprise Java development, because they're not. And yet Java tends to perform very well. And has, you know, historically and continues to. And just as strongly, again, you can't make it out in this chart, you have a number of other languages that run on top of the JVM, most notably Scala, which is sort of slowly inching up to the top of the second tier, that are, you know, also included in not the first tier of popularity. They're not in there with JavaScript, Java, Python, PHP, Ruby, etc. But they're quite popular. And they're quite, you know, they're not ubiquitous, but they perform very well in both environments. And again, this is a rare thing. So the point to sort of take away here is that even if we're looking at communities in GitHub and Stack Overflow that we consider to be predictive, that we consider to be reasonably representative of where things are headed and what sort of the developers who are driving things forward use, Java performs well, which may not be what you might expect if you're just looking at sort of raw commit numbers. Jobs, I'm sure many of you have seen these in sort of various pieces of analysis. This is just trends from Indeed.com. Indeed.com is effectively a search engine that sort of munges a variety of, or indexes rather, a variety of different job-related sites, and can give you trends in terms of the demand for particular technology, the demand in this case for particular languages. And this is the absolute chart, so this sort of measures the absolute number of jobs as opposed to the relative growth rate. But the point is that as popular as all these other languages that we talk about might appear, particularly the hot languages, JavaScript, PHP, Ruby, Python, etc., none of them approach the number of jobs that are available for Java. And none of them appear sort of headed on a trajectory, as we saw in the commit volume, where they're likely to. So, the point here is obviously quite simple, is basically that, when we look at sort of job data, when we look at the available employment data, basically what we see is a robust and sort of sustained job market for Java technologies. And again, this really hasn't changed as long as we've been doing these analyses. So it seems a little bit weird to us to suggest that enterprise application is dead, or at least enterprise application using Java, and yet the job market remains robust and is outpacing languages that might be considered in some context to be replacements for Java. We can't really square those particular conclusions. Likewise, we have list traffic. Have any of you seen MarkMail? We got the idea actually from some of you guys may know Dalibor Topic. He took a look at this years ago. I can't even remember how many it is now, probably at least 3 or 4. And he was looking at sort of comparative mailing list traffic. So what MarkMail does is that they ingest email traffic from a variety of open source projects. So they, these lists are public. They make them available. MarkMail goes out, sucks them all in, and can obviously plot, the distribution and frequency of traffic on these lists in terms of the number of messages being sent sort of back and forth. And there are obviously any number of query terms we could use for Java, but I wanted, in this case, to look specifically at the OpenJDK communities. So this is nothing more. If you go to markmail.org, if you go in and do sort of a query just for OpenJDK, this is what you'll see. And we actually saw similar patterns for a couple of other sort of Java-related projects. And again, what this indicates to us, aside from the performance on Stack Overflow, aside from the performance on GitHub, aside from the performance in jobs, is that there is continued discussion and growing discussion, more importantly, of Java, the project. So these are the kinds of things, when you start putting these together, it really challenges, in our view, sort of the notion of a decline. But the biggest thing from, at least from my perspective as an analyst, which really kind of throws into question the sort of supposed idea that this is a dead language is the fact that developers keep using it for projects. All right. So in some of these cases, of course, these projects are very old. The Eclipse project actually I think is, what are they, 6 months older I think than we are as a firm. So they've been around for a decade. So okay, fine, that's not a recent choice and so on. But when we look at projects, Hadoop is just a couple of years old. Cassandra is even younger than that. Neo4j likewise. What we see, in these projects, Jenkins Hudson, what we see in all these projects is that developers continue to choose Java. And not because an enterprise forced them to, not because they had to, not because somebody else made that decision for them. They chose it because it was a good solution to the problem that they had. And from my perspective, as long as developers continue to make these choices in terms of building key pieces of our infrastructure moving forward, the Hadoop ecosystem at this point is enormous. As long as these projects are still being built on Java, again, I can't build the case that it's a dying platform. I certainly can't build the case that it's a platform in decline. This is, again, a platform that sort of points to continued growth. But what about from a sort of company perspective? And I don't mean sort of the enterprise, the traditional Fortune 50, Fortune 100 business, who has extensive investments in Java. What about a company that has started more recently and has the opportunity to make, basically clean slate decisions? They tend to make some similar choices. Anybody know what this is? And if you're from that company, don't cheat. Okay, well, you're somebody who cheats. Anyhow, so these are the open source projects from Netflix. If you go to the Netflix open source developer page, what you'll find is 2-3 pages of these. These are projects that Netflix has built for itself, subsequently made available as open source. They have, I can't remember what the actual project total is. These are 20 that are based in Java, right? And that is the overwhelming majority of projects that are written there. And even a couple of the other ones, Asgard most notably, that are not written in Java are written in things like Groovy, that run on top of the JVM. So the point here is that even when you have an organization that is cutting edge, an organization that's successful enough that many of you may have heard this before, Netflix on any given sort of weekday night is responsible for 1/3 of the internet traffic in the United States. All right? So they're operating at a scale that very few businesses are, and what is their choice for the projects that they're running? To maintain that infrastructure, to test that infrastructure, in the case of Simian Army, to essentially try to tear that infrastructure apart for testing and so on purposes. They choose Java. All right? So this is a choice, again, that Netflix could have made. They could have picked a variety of different languages, and they didn't. So again, really from our perspective undermines, the case that Java is in decline. And Android, for all of sort of the legal issues surrounding it, and I'm sure many of the people in the room might have an opinion on that subject, whatever that opinion might be, one way or another. The fact is that Android has introduced Java, or introduced at least the principles and the semantics of Java to an entire new generation of developers. A generation of developers that isn't necessarily concerned with things like Eclipse, isn't necessarily concerned with things like Hadoop, but they just want to build an app. They want to build an application for the hundreds of Android devices that are out there running right now. So basically what we have is a language which, as we've seen, is sustaining, certainly its position from a popularity perspective, at least according to metrics. We see a language which is growing its mailing list traffic. We see a language that is, continually employed by core infrastructure projects, whether those are, sort of your typical multi-organizational open source, or whether in the case of Netflix, they're primarily authored by one company. And now in Android, you see sort of the relevance of Java, back on devices. Right? And again, it's sort of ironically come full circle, because if you remember from the outset, it was intended originally to power cable set-top boxes. And Time Warner reportedly rejected it because it offered too much control to users. And Android, all these years later, is still offering that choice to users. And in the process of doing that, it's bringing Java to literally tens of millions, if not hundreds of millions of customers worldwide. And then lastly, if you remember this I thought was a very interesting piece. If you remember the survey that we looked at earlier that indicated that basically you had sort of an increasing probability of using Java the older that you got, they surveyed, they being sort of Stack Overflow, surveyed 10,000 developers. And the interesting thing is of that study, almost 1 in 3 were using Java in some form or fashion. So again, when you survey 10,000 random developers from Stack Overflow's perspective, and you get almost 1 in 3, 31 and change %, who are on top of the platform, I'm not really sure how that's a dying platform. I'm not really sure how you build that case. It doesn't make sense. Has the language peaked, from a popularity perspective? Will Java ever be, again, as popular sort of on a relative basis as it was? Is it ever going to occupy the type of market share that it did 10, 20 years ago when it had less competition? No. Java in that sense has peaked. Java will never again, be that popular, never again be sort of that central. But everything's relative, right? The evidence from our perspective, again, we drive this home sort of over and over and over again because we hear sort of the opposite over and over and over again, is that the evidence from our perspective simply doesn't support the claim that Java is dead. Java is no longer as popular as it was, but Java is very, very popular indeed. And given the sort of context and the time limits for this particular slot, we chose not to go through every last piece of data, but I can tell you, if you want to build the case, the Java is, continues to grow. If you want to continue, if you want to build the case that Java's trajectory continues to be up, it's really pretty easy to find that data because there's a lot of it. So, as I said at the outset, we had 2 goals for this particular talk. The first was to trace the rise, the fall, and the rise of Java. But the second was to try to give you guys some ideas, to try to give you guys, sort of some thoughts in terms of things it might be good to see, things that might continue to ensure growth. And, there were a couple of different sort of examples that I'll point to. And this is one that, to be, I guess, candid, Java certainly has not always absorbed this particular lesson all that well. Easy, in most cases, tends to win over complex, even in cases where technology, you are sort of an inferior technology. So, one example that I use all the time, sort of trying to illustrate, the question of convenience is, I talk about Postgres. So many of you have probably used Postgres. In the mid part of the last decade, I had a conversation with some people from the Postgres community, and their question to us as analysts was, why are we so much less popular than MySQL? We have a better product, we're more performant, we have all these wonderful features that MySQL doesn't have. And while it's not this simple, one of the things that we had to point out to them was, we said, okay, hey, look, developers are increasingly picking their own sort of Linux distributions, and the trajectory from our perspective is clear. They're going, they're headed towards Debian-based distributions, and in fact, we believe that to be the case today. And we asked the Postgres team at that point, hey, how do you install Postgres on top of Debian? And they came back and said, well, hey, we're not in the repositories because of these other issues, but it's not a big deal. You go to the website, you download this package, you build it, and then you're off and running. And we had to sit there and say, hey, look, that's the point, right? That's the problem. If I have a choice as a developer, I'm trying to do 90 different things, and I want to implement something quickly, and I have a choice between 2 databases that are probably going to do what I need them to do, at least in the short term, and I can install one of them on the command line via a single command, and it will go, download, fetch it, install it, and do some basic configuration. And more importantly, now maintain that package for me over time, so I don't have to go back and update it myself. Or I can pick something that I have to go to a website, download manually, build, and install. I'm probably going to pick the easier one. Now, you can talk to me all you want about how much better your features are and how much, how technically superior your project is, but at the end of the day, that's not going to matter, at least in initial adoption scenarios. You know, when you get into huge production projects and everybody wants to benchmark, it's obviously a different scenario. But particularly in the early days, the ease of use matters. And you know, one of the other examples we point to here is Mongo. So again, many of you have probably encountered Mongo. Many of you may have strong opinions one way or another on Mongo. But what we talk about with Mongo is ultimately that it's almost taken sort of the MySQL proposition that much further. I mean, yes, it's in all these distributions, it's all these repositories, so yes, you can install it very easily, but it's more than that. You know, basically, the sort of promise for Mongo, and we hear this all the time from developers. Why do you use it? Have you benchmarked it? Did you hear this horror story that somebody wrote about it losing data and so on? And they say, yes, I heard that. It's unfortunate. I hope it doesn't happen. It probably will at some point. But it's just so damn easy. It's just so simple. You know, really, I download it, I unzip it, we're done. There's no schema. You know, there's no bindings. I'm just JSONing things in and out of it from really the minute it gets there. So these matter. You know, this sort of lack of friction matters. You know, and these are the kinds of things that otherwise, technologies that otherwise probably don't seem to have that much in common do. You know, so we've talked about sort of the MySQL example, but Amazon Web Services is another perfect example of this sort of tendency at work. You know, there's a piece going around today, I think it was written yesterday, the day before, about Amazon's performance and price performance and how it's subpar and it doesn't compare to dedicated hardware and so on. But the fact is that it's just easier. It's just easier, it's faster. And the example that I talk about here, I have a friend of mine who works for a Fortune 100 organization. He runs infrastructure. He comes back to me. He's been sort of working nights and weekends, 6 months, trying to improve their provisioning time. And he comes in, he's all excited, and says, "Yeah, this is great. We improved the provisioning time by an order of magnitude." And I was like, that's great. What did it go from? He said, "Well, it used to take us weeks." I was like, "Okay, that's pretty bad, but certainly not unheard of. What is it now?" He said, "It's awesome. We can usually do it in the same day." Not always, but usually. And I had to sort of take a step back and say, that's great, but you may want to kick off another one of those 6-month projects. Because the expectation now isn't same day. The expectation now is 90 seconds. It's that convenience that trumps just about everything else. And again, this is not the kind of thing that historically Java has tended to do well. Many of you, I'm sure, have, actually, do we have anybody in the room who's responsible for the DLJ licensing? Okay. Many of you in the room probably have experienced some of these yourself. They couldn't get Java into many of the Linux repositories because of licensing incompatibilities and so on. Some of the folks at Sun tried to jump through a lot of hoops to make that happen. So there have been efforts to improve in this regard, but as you move forward, as you want to sort of build, grow, improve the Java community, this is one of the things that I would point to. Try to remember that it's not the technology in many cases that's going to make the decision. It's how easy it is to use, how easy it is to access. And that gets completely lost. People ask, why did PHP win sort of the web war over Java, in spite of some of the best efforts of companies? One of the answers was simple. PHP was everywhere. You could get it on any server of any type, anywhere. We talked to Sun a long time ago and said, hey, look, we've looked at the top 20 web hosts as defined in this sort of shootout, and only 3 of them are offering Java, and 2 of those are only offering it on their managed boxes. You can't get sort of a low-cost Java environment. So no surprise, it didn't get used as much. So really think about easy, really think about frictionless access and so on. Frameworks likewise matter, and they matter a lot. One of the things that we've looked at in the RedMonk top 5, and this again is these are the Q1 numbers. In the RedMonk top 5, this is sort of a rough ranking, and frankly, the actual placement isn't nearly as important. But this is sort of interesting to us. And this trend extends well into the top 10. What we see from a lot of the emerging languages is that they tend to be dragged along, in many cases, by a framework, by a popular framework that solves a problem. And they do this, sort of in part by providing sort of a center of gravity, providing an area of focus. And when we look at Java, when we compare it, it's tough. This is the top 20. This is an article from this past fall. This is a graph, trying to compare the relative merits of the top 20 web frameworks for Java, for the JVM. Top 20. Now think about it from the perspective of a customer. If you're a customer, you have a website, you want to build it. A lot of customers and even a lot of developers are going to look at this and say, all right, I'm going to use Rails or I'm going to use Django. Or if I want to use Java, all right, I need to do an evaluation of the top 20 frameworks. That choice is difficult. There's a great book by a guy by the name of Barry Schwartz called The Paradox of Choice. And if you go to, I believe this is still true, I did it a week or two ago, if you go to javasource.net and you look at open web frameworks, I think it's 67 web frameworks are listed. All right? So the point here isn't go out and destroy all these other frameworks or go out and destroy the sort of diversity that the Java world has come to be known for. But the point is basically that as you move forward and as you want to encourage usage, volume adoption, and so on, you need to think about these questions. You need to think about trying to reduce or simplify the choice, because at the end of the day, the people who are have to make that choice right now probably don't care very much. They want an easy answer and they want it to be fast. And then lastly, frameworks are evolving. Some of you who have, who in the room have probably had experience with some of the heavier weight Java frameworks, J2E and which became JE and so on, was obviously a super heavy framework. I used to have the chart in my cube. It was 3 by 4, and you need a magnifying glass to read it. That's changing, right? We're moving away from those huge heavyweight frameworks that solved every known problem. And Spring was sort of one of the first trends there. Tried to simplify some of the tasks in the Java world. But then it was really frameworks like Rails, which came along and said, all right, yeah, there's a bunch of things we can do. We're going to solve one problem. We're going to build web applications. We're going to do that well. We're going to do it fast. And that continued this sort of multi-year trajectory towards smaller frameworks. And we've even seen sort of recently the continued evolution into micro frameworks. So things like Spark, Bottle, Flask, all of these very, very tiny, very, very lightweight frameworks are now being used to compose applications. They're being used sort of discreetly as sort of more minimal crutches than the heavier weight frameworks that they're being used sort of in comparison to. So while there's been some sort of incorporation of this in the Java world, as you move forward looking at frameworks, this is one of the things I would encourage all of you to take a very, very serious look at. And then, sort of obviously there are a lot of evolutions from a functional standpoint. One of the most important recently, I'm sure you've all heard, if not used, Node.js. Asynchronicity, this is one of the things, we had all sorts of people coming back to us saying, why is Node so popular? Why are people looking at it and so on? It's just another framework. And the answer is, it really wasn't just another framework. It certainly wasn't the first asynchronous framework. There was lots of things that predated it, the market twisted and otherwise. But the fact is that this was one of the first really popular frameworks that came along and said, yeah, we're going to do things very differently. We're going to essentially embrace the asymmetry and enable different types of applications. And by design, that's actually going to make us worse at some applications. Very much like you see people trying to shoehorn Rails into standard applications instead of try to build websites. It doesn't work. But the point here is basically that they're not trotting out the same application framework over and over and over again expecting to be successful. They're not just cloning existing frameworks. They're trying to do something fundamentally different. They're trying to do something new. So again, as you're out there, think about how frameworks have typically evolved. So when you build interesting applications, if there are interesting pieces of them that you continue to build over and over, like Rails was extracted from, what was it, Basecamp, I think, at 37 signals. Django was extracted from the website from the Lawrence Journal Bulletin. Look at the applications you're building. There may be sort of really interesting frameworks that can come out of them. But again, try to look around and try not to create yet another one and yet another one and yet another one and add to the problems of choice that we just mentioned. And with that, I have 1 minute left to take any questions you might have. That's a great question. So the question essentially is that the AP curriculum sort of shifted to Java 15 years ago. So, how do we sort of account for, the differences in age, effectively? How do we account for the fact that, look, if you take AP computer science, you need to be using Java, but we see less, sort of kids using it? I think there are probably a lot of different answers to that, but basically what it comes down to is that, curriculum, unfortunately, we did a sort of analysis of this not too long ago in terms of, looking at the sort of curriculum compared to the available jobs. We just scanned, I think it was the top 15 or 20 university curriculums, from a Forbes list that was online, and they're not terribly reflective of demand. They're not terribly reflective of where things are. Curriculums tend to be very dated, and therefore, in our experience, students depend less on them. So a lot of them certainly will have been exposed to Java. A lot of them, will certainly have, received some Java training along the line. But very few of, sort of, particularly the cutting edge guys today, are relying sort of entirely or heavily on their school education. They're instead supplementing that with actual experience in terms of, coding, open source projects, sort of internship work, and in some sort of, increasing number of cases, it's difficult to say how many, through, very alternative channels, in terms of MOOCs and, other online learning opportunities. And with that, I think I'm out of time, so I just want to say thank you very much. It's been great, and I'll be around for a little while if people have other questions.